All right, so first I just want to say a couple of things about advanced instruments, and then we'll go through, some details around the Anoxomat. I'll provide a brief introduction of myself, so you know who the floating voice is, and then we'll get right into demoing the instrument. So who are we at Advanced Instruments? We see ourselves as a leading developer of scientific and analytical instruments, consumables, and services. So we're really all about increasing productivity and ensuring quality, not only in clinical, but also in the biopharma and food and beverage spaces as well. We're actually headquartered in Norwood, Massachusetts, so just outside of Boston, Massachusetts. But we have offices in Wimborne, UK, that support our Solentum product line, which you can see down at the bottom right-hand side of the cluster of pictures there. And in Westbrook, Maine, where we support our Artel products, so pipette calibration verification products, as well as pipetter training for your folks in the laboratory who need to meet compliance or improve their pipetting skills. So we were founded way back in 1955, actually, as a distributor. And once we identified a broader use for the modality of all our osmometers here at Advanced Instruments, freezing point depression technology, we really became a provider of clinical and industrial technologies. So we introduced the osmometer and rebranded ourselves as Advanced Instruments. And since then, we've really established ourselves as the gold standard in osmolality testing. But playing on our different strengths, in technology and development, quality and support, as well as customer collaboration and partnership for workflow integration, we've really been able to grow as a global business and support a much broader application of technologies outside of osmolality alone. So here's where we are in the world. The colored dots notating where some of our global headquarters are, but really we provide products to all of these different spaces, including the clinical space, everywhere from North America to South America, Europe, the Middle East, Asia, even way down in Australia as well. So serving 90 countries around the globe. I'm super proud of everything that we do and the quality of results that we can help you provide your physicians. Okay, so I talked about all those different technologies that we've since developed, expanding off of our osmometer product line, which you see all the way over here on the left. So our osmometers are really, when folks think Advanced Instruments, this is probably what you see in your head. You see one of our osmometers, maybe the Osmo One, which is the little single sample one on the right there, or the Osmo Pro, or maybe even our newly launched Osmo Pro Max. But we do other things really, really well here as well. And again, I can speak from experience as somebody who used the Anoxomat system that this is a game changer for your microbial workflow, especially for those labs that are growing a lot of anaerobes, microaerophiles, even capnophiles, or if you just want a custom gas environment for something that you're growing in your laboratory. So some other products and services that we provide, if you look over here on the right, we also have a GlowSight automated CSF cell counter. We're actually going to be having a webinar on this product on Thursday. So the same link that you would have used to register for this webinar. If you're interested about learning more about this product, how it works, the value that it can provide you and your providers, as well as patient care, you can tune in to that webinar on Thursday. But what the GlowSight automated CSF cell counter is pretty self-explanatory based on the title. But it is an automated cell counter that really helps you replace more outdated manual methods like counting your cells on a hemocytometer, right? So no more hunching over the microscope, no more loading your hemocytometer, waiting for your cells to settle, keeping the moist environment, kind of juggling all the different tasks associated with the manual method while you're doing everything else that you have to do in the laboratory. And then even more important, this technology is linear down to 0 cells per microliter. So considering that, normal range for your total nucleated cells is anywhere between 0 and 5 cells per microliter, this is going to be really important in making sure that you can get the most accurate, meaningful information possible from your cell counts. Get those results in under 5 minutes. And then all the way over here on the right, we have our BR2 bilirubin stat analyzer, and that is for total and direct bilirubin measurements. All right, moving on. So let's talk about the AnoxomatIII. So the AnoxomatIII really includes everything that you see here. So you have the instrument itself, which you see there in the middle, a plethora of different jars, which I'll show you more about when we get into the demo portion of this presentation. We have a printer and an external scanner, which are really helpful not only for your printouts and keeping a paper trail, but for something called the track and trace feature of the Anoxomat software, which I'll show you more about later in the demo as well. And then down there at the bottom, you see these little sachets that come in the little plastic tub with the blue lid. That's Paladox. And really, that's a palladium catalyst that removes any residual oxygen from the jar, following the cycles of atmosphere generation. And we'll explain a little bit more about how that works and why we need to use it for our anaerobic cultures later in the presentation as well. So as promised, this is a younger version of me. When I show up on your screen here in a few seconds, I'm going to be much beardier, if that is a word. But I am a microbiologist by trade, so I'm actually a medical laboratory scientist. I was ASCP certified before I crossed over into industry and left the laboratory. But I spent a lot of my days for many years on the bench just like this, looking into a microscope, growing a bunch of different bugs, observing sometimes a bunch of other types of microorganisms, maybe something like you see over here on the right, Nascaris lumbricoides, or maybe something that you might see over here on the left. I think we all know what that is. That's a slimy Klebsiella, McConkey agar. So I do love microbiology. I did use the Anoxomat system for many years as well for culturing all of the anaerobes that I grew when I was in the laboratory. And I can tell you that it is a really efficient, robust system that really provides you the peace of mind of knowing that the anaerobic environment you created will stay that same environment the entire time this jar is sealed. And there are a bunch of different measures that we put in place to confirm that when using the Anoxomat system. So we'll get into that as well. All right, so enough about me. Why do we do this, right? I think most of the folks on this call know what these bugs are and why we culture anaerobes, but I think sometimes it's interesting just to have a little bit of a reminder of what we're doing for our patients, what these results are used for, and why they're so important. So when you're looking at an organism like Fusobacterium necrophorum, something that causes something that they call Lemierre syndrome, these patients sometimes present with pharyngitis, right? So a really sore throat. They'll have a fever, they'll have neck pain on one side. Sometimes they'll have a mass like what you see in that picture, and it's really tender. And what that mass comes from is something called JVT. So it's jugular vein thrombosis, which really is indicative of a Fusobacterium necrophorum infection. And this can lead to really serious side effects, not side effects really, but comorbidities like septic shock or even death. Another example of why we do this, Bacteroides fragilis. This is a common cause of intra-abdominal abscess. So sometimes these abscesses, which are walled off, can create really an ideal anaerobic environment for these bugs to thrive and grow. And they're associated with abdominal discomfort, just generally. So it's really easy to improperly diagnose something like this, which is why it's so important that we have tools like this on hand to quickly get an identification of these bugs and figure things out for our patients as soon as possible to get them on the right treatment and on the best track as soon as possible. And everybody's favorite, all the way over here at the right, this is the one that you can smell as soon as you open that jar up, Clostridium perfringens, right? This causes gangrene. So we all know what that means. Gas into the skin, drainage from the tissue, discoloration, pain. It smells terrible. And the treatment can sometimes be painful or even life-changing. So really, really, really important that we're able to know exactly what these are when we first see them in culture, and that we're able to create the environment that they thrive in so that we can effectively grow them in culture, most importantly. Okay, enough looking at those pictures. So again, why is this so important? Well, our anaerobes are often associated with some very serious conditions. And those conditions are associated with significant mortality, right? We're looking at 13%, which maybe that doesn't seem so large when you look at it as a standalone number, but that's 13% of patients who are growing an anaerobe. So it is pretty significant, which is why it's so important to detect these as soon as possible. So the incidence of these clinically significant bacteremia is greater in the presence of other comorbidities. So usually our patients who are suffering from things like a hematological malignancy or liver failure or diabetes mellitus, or maybe even somebody who just went through a gastrointestinal surgery, will sometimes see that these pop up. Another thing that we use anaerobic culture for is checking for what used to be called Propionibacterium acnes, now Cutibacterium acnes, after orthopedic procedures. So there are a number of different reasons that we need to be able to create these environments consistently and effectively every time to make sure that we're growing these bugs the best we can. All right, with that said, we're going to get into the fun part, and we're actually going to go demo the instrument. So I'm going to go ahead and stop sharing my screen here. And what you should see in front of you is the AnoxomatIII instrument. And I'm going to go ahead and come around front here and just briefly introduce myself one more time so you can put a face to the name. Hi, John Flasher again, former medical laboratory scientist. What I do here at Advanced Instrument is I'm a clinical product manager, both for the osmometer product line, which we had talked about on the cover slide, as well as the AnoxomatIII product line. So really excited to show you more about this instrument today. So as I showed you in the picture, this is the instrument itself. This is the AnoxomatIII instrument. Pretty plain and simple, not a lot to it. It has this sleek design with this black cover where the LCD screen actually lives, and we'll show you more about what happens in the user interface. And all it really has for you to interact with, other than the touchscreen, is the start button. And we'll give you an up-close look at that too when we dive into the user interface. It can also come with this printer, which you can attach so that you can manually print your QC parameters, as well as other information about each of your jars and cultures that you can program to print out on your printout. And I'll show you what that looks like later on. And it also comes with a scanner, so you can scan some of that information about your cultures or about your jars into the system as well. When I come over to this side, you can see some of the different jars that we offer for atmosphere generation in the AnoxomatIII system. The biggest one is our 36-plate jar. This is a legacy jar. This has been around since the early AnoxomatIII instruments. I used these when I was in the laboratory. And they're bigger, they're heavier, they're made out of a really durable, robust acrylic material. And they screw on and screw off with these clamps on top. We also have these jars, which are primarily used to house microtiter plates. So you can see the square rack that we currently have in the jar that is used, not really square, I would say it's rectangular, that is used to accommodate the stacking of microtiter plates within that jar as well. So the width and height of that jar are specifically designed to be able to accommodate that rack and any microtiter plates that you might want to use for atmosphere generation as well. Okay, so our newer jars, these are really cool. These are our ergonomic jars. This jar right here does 2 stacks of 6, so it will actually hold 12 plates. Uses 1 sachet for those cultures in that jar. And then this one will actually hold 2 stacks of 12, so it holds 24 plates. You can use a couple sachets in there as well of Paladox for culturing anaerobes in there. And what's neat about these is, as you could see before, they have handles. So once you create your anaerobic environment, you can easily walk over to the incubator, place the anaerobic jars into the incubator. And when it comes to incubator space, where maybe these big jars kind of fall short in terms of accommodating the most incubator space, using these smaller jars allows you to kind of fit them together like a puzzle piece. Because they're shaped like little circus peanuts, you can kind of stack them into your incubator with more efficiency and create more space with more cultures and hopefully free up some, precious incubator space that a lot of us don't always have. So that's all of our information on the jars. This is Paladox. So what comes in this little tub with the blue lid is Paladox. It's just a palladium catalyst that removes any residual oxygen out of the culture after we actually generate the atmosphere with the instrument. So we'll get into why that's important later on when we do a run as well. And these are our hoses. So this instrument is set up to connect to up to 3 jars at a time. And you can actually connect these to all 3 jars if you want to. And you can go ahead and run it. And the instrument will detect all of the jars that it's connected to and go ahead and create the environments in every jar. So that's pretty cool, but you can connect just 1 if you want, or just 2. It doesn't really matter, but you can connect up to those 3 with this configuration. And those just easily pop off there. So another thing that's this instrument accommodates is up to 2 gas inlets. So if you want one tank that just has all CO2 and another tank that has the other gases that you need for your anaerobic mixture or whatever gas mixture it is you're trying to accommodate, then you can have both of those gas inlets connected from those different gas sources to the instrument, and this instrument will accommodate that just fine. So it does require an external gas source all the time. So it needs to come from somewhere. So you usually go to whoever your medical gas provider is, be it Airgas or another company, to coordinate the purchasing of the materials like the gas canisters, as well as the regulator, which regulates the pressure of gas. Let's see if we can get a good look at it. Pressure of gas that's being pumped into the instrument, which is going to be super important, as well as any hosing that's needed. So if your gas tank is really far away, then you'll have to get some hosing for your instrument as well. But it is really important that you have an external gas source, not unlike a chamber, but you'll use significantly less gas with the Anoxomat. I'll touch more on that a little later too. Okay, so that is everything that comes with the instrument. So with that, I think what we'll do is we'll just take a look at the user interface. If I can get my button to work, and I finally did. Okay, so this is what the Anoxomat system will actually look like on its home screen. So as I mentioned before, it can accommodate anaerobic recipes, it can accommodate microaerophilic recipes, and it can accommodate custom recipes. So if you were to just set up an anaerobic culture, you would simply just select anaerobe. You would place by simply unclipping the top of the jar like this and pulling up. You would place a Paladox sachet into this nice handy little holder in the middle, into your jar. Then you would replace the lid of your little peanut-shaped jars, and then you just clip it shut. And that's where you would actually connect your hose and create your anaerobic environment. Because my quote-unquote lab here in the Norwood Media Room is not set up with an external gas source that can accommodate an anaerobic environment, I'm not actually going to run this. I'm going to show you what a microaerophilic run looks like. But I just wanted to show you the process for the setup of what I'm assuming is the majority of the culture types that you'll run with this instrument. So that's all you would do. And that sachet is going to be good for as long as you have the environment closed. But each time you open it, you'll add a new sachet and you'll regenerate that anaerobic environment. So let's say your laboratory workflow for anaerobes is checking for a preliminary result, any potential growth every 48 hours. You'll go in at the 48-hour mark, you'll open your jar, you'll go through, observe your plates, your preliminary result, maybe no growth, maybe usual flora. Then you'll put your jars back in, give them more time to incubate for whatever the duration is that you hold onto your anaerobic plates in your laboratory. Okay. Let's go back down and take a look at this. So as I mentioned before, we have a microaerophilic recipe, and then we have saved recipes. And when we click into here, you can see a bunch of different recipes that we've actually saved on our demo instrument here in Norwood. But you can actually go through and adjust all of the different percentages of gas that will be included in all of these custom recipes. And you can save a bunch of these. So you can really save as many recipes as you want and select any one of these recipes at any given time to generate that atmosphere in your jar. And the way you do that is by clicking this button in the middle where it says Program Recipes. As you can see, it shows you everything that I already have in there, but it also gives me the option to select New Recipe. And you can see that it's as easy as naming it and using these toggles to select the concentration, nitrogen, carbon dioxide, hydrogen, and oxygen that you want in the custom recipe that you develop. So I can just go ahead and use this toggle down here. And you can actually see on the right, my oxygen concentration going up. So we'll put that at 7.2. And you can kind of use these to adjust the ratio of gas that you want in any given recipe. So that's a pretty neat function as well if you're working on something really niche that requires a custom environment, maybe in the research environment, maybe in the clinical environment if you're crafty, but just something else that we can consider when using this as well. All right, we'll go ahead and back out of there. So what I'm going to do now is, like I said, because I'm not set up to run anaerobes here in the Norwood demo room, is I'm going to go ahead and just do a run with our microaerophilic recipe. So I'm going to just go ahead and select that. Again, I'm going to try to work all the camera angles here so you can see the whole process. I'm going to go ahead and attach this after I've loaded all of my cultures into the jar. And then I'm going to go back here to the software. All righty. And then where this green button says start, I'll already have my selected recipe emboldened. I can just go ahead and hit that green button. And it's going to start a process. And you can see that there are different columns along the checks on the bottom of the screen. So the first thing that it's going to check on the top, where you see that first little green check, is the incoming pressure from the external gas source. That's why that regulator is important. The second thing that it's going to check are which jars are connected. Remember, I showed 3 possible jar connections. For this, I only connected 1 jar. So the instrument automatically detects which jar you connect, and that's jar number 2. All right, the next thing that it's going to do is check for leaks. So it's going to make sure that that jar is sealed and that no leaks are present that could compromise the integrity of the atmosphere that we generate within the jar. So it'll do that leak test and it will do a seal test. The next thing that it would typically do when you're creating an anaerobic recipe would be a catalyst test, which would confirm that the catalyst that you put into the jar is functioning as intended. And then once it hits all of those different QC metrics, it knows that it has your anaerobic environment or your microaerophilic environment or whatever environment that you want. It has it completed and maintained within a leak-free, completely sealed jar with a working catalyst. We'll go ahead and let it take the rest of the steps here. So typically for an anaerobic recipe, this can take about 5 minutes. Because this is a microaerophilic recipe, it works a lot quicker. So you'll see these green checks pop up in a hurry. Once that seal test is complete, then my jar will be ready to go. So the seal test is complete. It has no need for a catalyst check. So it's just going to go ahead and stabilize the pressure. And then you can see under the jar 2 row, that column where it says ready is checked green. You get this little printout that'll give you all of those QC metrics as well. Connected, leak, seal, catalyst, everything all okay. It'll show you the incoming pressure, the recipe that you were using, and the date and time that the jar was filled. So on that point, while we have a few more minutes, another cool feature of the AnoxomatIII system is the setup feature. So there's a setup code for every instrument that will actually come with your delivery. For this one, it's that Mark 1598. And when you go into setup, there's a bunch of different options you can select from. Some help you with touchscreen options, some help you interface your instrument, others help you set the date and time and language and test your printer connection, you know, a lot of really basic kind of mundane things that we see on a lot of instruments. But what's really cool is this registration page. So here you can actually name your lab and the department or lab, and you can say instrument name if you really want to be creative. You can register different users, so you can have specific user profiles. So if I wanted to make sure that everything that happens on my instrument is tied to a specific user profile, you would assign a name and user code to a person on this menu. Because we only have a couple minutes and I really want to show you this other feature. I'm not going to do that. So I'm going to go back to registration. there's this awesome feature called jar setup. So if you're a laboratory that runs a lot of anaerobic cultures and you want to make sure that you're effectively keeping track of when you've set up each jar and when the necessary time is to open those jars to check for growth, like I said, maybe it's the 48-hour mark for your laboratory. A really cool feature that you can use is the track and trace or jar setup feature, where you can select different information that you require your users to put into the system before actually running an anaerobic recipe, or really any recipe. So I'm going to select jar ID, sample ID, and incubation time. I'm going to select the ability to put in multiple IDs, and then I'm going to select this pre-scan option here and hit close. So when we go all the way back to the beginning and we try to, again, work the camera angles, run another recipe, we're going to go to the menu here and select our microaerophilic recipe, and we're going to select Start. It's going to do the same thing that it did before. It's going to make sure that that incoming pressure is adequate. It's going to test which jar is connected. It's going to show me that I haven't connected a jar because I didn't depressurize the jar that I used from last time, which can happen. So we're going to try this one more time. So as you can see, I used the jar 2 hose again. It's detecting the hose. But this time, instead of going right into the jar filling or the anaerobic environment creation process, what it's going to do is populate this screen that allows you to scan in the jar ID so you can see where the cursor's on jar ID. I'm going to go ahead and scan a barcode that I have associated with that jar. And you can see where that barcode populated into ID. And then you can do the same thing with all of your patient samples as well. So let's say I've got a rack full of anaerobic cultures that I want to put in, and I'm going to go ahead and just go down and scan a few. Those will all populate into your user interface as well. And then I can actually say, hey, I want to come back and look at these cultures in this jar at the 48-hour mark. And then once you're done selecting everything there, you just hit that start button again. So the same thing as last time. It's going to go through and perform the leak test. It's going to go through and perform a seal test. It's going to skip the catalyst test because we're doing a microaerophilic recipe. And then it's going to show that our jar is ready. The only difference is that this time, and if you stick around, I'll show you exactly what it's going to look like. But this time, it's going to print out with an anticipated preliminary result check time frame. So it's going to tell you at exactly 48 hours to the minute after the culture was set up. It's going to give you a recommended time to go in and actually open up that jar or check your plates for growth. So that said, I know we're coming up right on the half hour. I do promise I will show you that printout once it prints out. But for those of you who are stretched on time and maybe only allocated 30 minutes, I do want to give you the opportunity to ask a couple questions while this run finishes up. So Adrian, are there any questions in the chat that I might be able to answer?
No questions so far. They love your camera angles.
I'm trying to work it. Thank you. I appreciate that. All right, we're going to take another look at the screen here. So again, leak test, make sure the jar is connected. We're going to move on to the seal test and then on to ready. And I'll just show you how great this is because you can take this printout and just stick it on your jar. Let's say you have one shelf that corresponds with cultures that were set up on one day, another shelf below that that has cultures that were set up on the subsequent day. You'll be able to stick this label, this printout, onto each of the jars so you know exactly when you should be going in to open each of them up throughout the day. You can make sure that nothing gets open too soon. Make sure that they were given adequate time to incubate in that anaerobic environment before you go through and have to recreate that environment one more time and let it go out the rest of the culture duration. All right, so we'll be moving on to ready right now. And I'll go ahead and show you what that looks like. So you remember the last printout? This has a lot of similar information, the date and time that it was set up at the top, the recipe, but you're also going to see jar ID. So that would be the barcode associated with the jar that I used. You can also manually enter that, so you can give your jars clever names if you want to name them all after the seven dwarfs, or get really creative and name them after planets or moons of Jupiter. That's cool too. And then for sample IDs, you can actually see that each of them are separated by the number symbol, and you can actually select what separator you'd like to use for your sample IDs. This is usually going to be the accession number that's associated with the cultures that you put into your anaerobic culture jar. And then here is the information that I was talking about before. So it will tell you that the incubation will be finished on February 13th, 2 days from now, February 11th, at 3:25. So well, not exactly, because I don't think this instrument has been adjusted for daylight savings, but very close to 48 hours after we set up that initial culture. Again, it's going to show you what gases went into your recipe, what the pressure was, and that all of your QC has passed as well. So if you do need to hold on to this for an audit trail, you can do that as well. But also a great indicator as to when you should be opening each of these culture jars. Okay, so a little bit over time, but that is our overview on the AnoxomatIII system. Again, it's a really great instrument. I used it when I was in the laboratory for many years. It provides you a lot of advantages over sachet-based systems where you're kind of putting that anaerobic strip, that O2 indicator strip into the jar and hoping that the color changes so that when you come back the next day, you don't have to set it up again, and really provides you with an option for considerably less gas consumption over chambers, sometimes about 10 times less gas consumption over chambers. So if you're considering a more complex, big, clunky option like that, that constantly needs to have its anaerobic environment replenished, this provides you with a more controlled, step-based anaerobic environment creation that can really help you limit your gas spend. So with that said, Adrian, if there are no questions, I think we can let these nice folks get back to their day. But if there are, I'd be happy to answer them.
No question on my end.
All right. Well, thank you all for joining. I hope you found value in this presentation and you're as excited about anaerobes as I am. If you have any questions, please reach out to Adrian or your local rep or myself, and we'll be happy to answer them for you. Have a wonderful day.